let me show you how to find the slope so you end up feeling like this guy.
Ninja Cowboy!
Alright mathletes, so let's jump in here, and today we're going to be looking at how to find the slope of a line. So you could be given 2 points, or they could just give you a line, whatever the situation might be. Alright, so first of all, what is a slope? So the slope is the steepness. Pretend this is like a hill. Of course it's not a hill, but let's pretend it's a hill that you're going to climb, and it's going to tell us how steep this hill is, right? So the bigger your slope, the steeper the hill that you're going to climb, right? So, and you always want to think about that you start on the left-hand side. So if I were to draw a mini Dr. Math here, right? Starting on the left-hand side, and are you going to be walking up or down? So from left to right, since I'm walking up, then you know it's a positive slope, right? And if I were to look at this one right here and walking from left to right, I'll be walking down the hill. So that's why I have a negative slope, all right? So that's what we're gonna be thinking about as we're finding these slopes. And of course, let's pretend you were on a treadmill, and you were on a treadmill here, and at slope 0, right? The very beginning, once you jump on that treadmill, it's just going to be a flat horizontal line. So this is a slope 0. And what you're going to see here is whenever you have a slope of 0, the y values are going to be the same of the 2 points that you're looking at. So we'll talk about that. And an undefined slope is a vertical line, just like this. And what you're going to see is that they're going to have the same x values, right? Because if you try to climb this, you're not doing that unless you're Spider-Man. All right. So how do we actually find the slope? Well, what they need to give you are 2 points. And what we're going to do is we're going to call one of the points point 1, the other point point 2. Does it matter? Absolutely not. Regardless of whatever point you call point 1 and point 2, this will always work. And so when we think about the slope, we think about the rise. And when you think about the rise, I know rise is going up, but you're really thinking about how much you either go up or down, right? If you're going down, that's how we get the negative slopes, right? And so the run, the way I like thinking about it is how much we're moving to the right, since I told you we're always going to start at the left. All right, so how many places do we go to the right? All right, so let's go ahead, let's look at some examples and see how do we use this formula to find the rise over run, the slope. And one last note, whenever you talk about rise, a lot of books are going to use a triangle y and a triangle x, and what this means is the change. How much are you going up by? How much are you going down by? And the change of x, delta x, is how much are you moving to, in this case, the right. What's the change in the x direction? So whenever you see this just means the difference. What's the difference in the y values? What's the difference in the x values? Just in case that was confusing if you've seen that in the past. So let's jump into this. All right, so let's go to our friends over there at mathwarehouse.com, and I just took one of their pictures here just to show you. So here, if I were given an image, a picture here, a graph, I could take 2 points and I could say, all right, how much do I move up? What's my change in the y direction from this point to this point? So notice I go up 1 unit, so that's why the rise is 1. And how much am I going to the right? Well, I'll go over 1, 2, 3, 4. So the y, or the x, the change in x is 4. So the change of y divided by the change of x. But how does this look using our formula? So let's write down our formula. And people always ask me, Dr. Math, do I have to write down the formula every time? And I say, stop writing it once you understand it or memorized it. That's when you stop writing it, right? So every time you're using it, write it down, and it'll get burned in your brain, right? So I have 2 points here. So I'm gonna call this x1, y1, and what's awesome is it doesn't matter. And I'll call this x2, y2, right? So again, -3 is my x1, 0 is my y1, 1 is my x2, this 1 is my y2. So we're gonna plug everything in here. All right, So we get y2, which is 1, minus y1, which is 0, divided by x2, which is 1, minus x1, which is negative 3. And this is where I really want you to make a careful note. When you have this negative number, put it in parentheses, because what a lot of people do is they make the mistake, and since this is a negative, they'll just write a 3 right there, assuming that negative is taken care of. So no, make sure you put the parentheses there, because people make that mistake all the time. All right, so jot that down. So this equals 1 divided by 4, because, let me do this off to the side for you guys. When you have a negative and negative, remember that's a positive. So we end up with 1 plus 3, which is 4. So that's how we get the 1/4 there. And this matches exactly what we expected, right? We go up 1, starting at this point, we go up 1, and then right 4 units. And that's what that means there. So there's my change of y divided by my change in x. Just so you get used to this notation, because you will see it later if you haven't seen it yet. All right, how we doing? Good, follow me to the next problem. All right, so now we get an example of a negative slope. So notice, to go from one point to the next point, I would have to go down 2 units. So that's why your rise, in this case, would be negative 2, right? That's the change. And then how many do we go to the right here? 1, 2, 3, right? So notice, I have negative 2 on top and 3 to the right. My friends over there at Math Warehouse, they have the run as negative 3. And again, I wanted to show you what they have here so that when you go off to these different websites, you don't get confused. The only thing is, and this is the easiest way, I've been doing this for too long, and the best way to look at this is draw your little Dr. Math person right here and have them always walk to the right, right? Have them walk to the right. Is he gonna walk up or downhill? He's walking downhill. So that's why it's a negative sign right there, right? And so since I'm walking downhill, bam, I got a negative number right there. So what's awesome about this, when we do this by hand, this negative sign, I could write the negative upstairs in the numerator, or I could write it downstairs. But typically, right, we want to write it in the numerator or off to the side. All right, so those mean the same exact thing. So technically, you know, what they wrote here is not wrong. It's just a different way of thinking, and that's why I wanted you to see this. All right, but I really want you to use kind of the logic that I'm pointing out. Since I'm going downhill, the number on top, which represents my y, is going to be negative. Does it matter? No, I just don't want you to get confused with the notation. So let's plug these numbers in. All right, so I'm going to call this x1, y1. I'm going to call this x2, y2. All right, so let's write down my formula, because again, we stopped writing it once you memorized it. All right, so y2, so m equals y2, which is negative 1, minus y1, divided by x2, which is 3, minus 0. And what's awesome again is if I switch the signs, it doesn't matter, we get the same answer. All right, if I switch the order, if I call this x1, y1, x2, y2, we get the same answer. And that's the beauty of this. So negative 1 minus 1, we get negative 2 divided by 3, just like we expected, right? So hopefully this is making sense. All right, so now let's talk about a potential problem child. Follow me. All right, here's a potential troublemaker. This is what usually gets people, because they see a fraction and they forget all the rules. So again, just because it's a fraction, the math hasn't changed, right? So I'm gonna call this x1, y1, and then x2, y2, right? And I could reverse the order, doesn't matter. So let me write down my formula, because I want to find the slope going through these 2 points. So y2 minus y1, x2 minus x1. All right, so let's go ahead and plug everything in. So my y2 is negative 4, minus y1 is 3, divided by x2 is 3 halves minus x1 is 1 half. All right, so negative 4 minus 3, we get negative 7. And on the bottom here, I'm going to do 3 halves minus 1 half. What's nice is the denominators are already the same. If not, you make them the same, right? So we're left with 2 divided by 2. So again, just a little heads up. All we do is subtract the numerators because the denominator is the same, so we leave it the same. So 2 divided by 2, that's the same thing as 1. So our slope is negative 7 over 1. And if you want, you could simplify that to be just negative 7. So there's your slope, folks. All right, so again, this is a slope formula and you're gonna be using it all throughout math in different math classes. So again, make sure you understand it, make sure it makes sense. And again, the most important step here is don't forget to subscribe, like, and we'll see you mathletes in our next video. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching and we'll see you guys next time.